So let's spot check the first one. So 4 is outside, correct? Okay. So that's going to be 4. 54. What does 54 break down into be? What? 9 and 6. So that's going to be the square root of 9 and the square root of 6. Why is the square root of 9 important? It's what? It's what? It's what? 3. And 6. Can I break down the square root of 6 more? No. So my answer here is 12 square roots of 6. So this would be the square root of 12 times the square root of x squared times the square root of y to the 5th, right? Okay. Square root of 12 is the square root of 4 times the square root of 3. The square root of 4 then is 2. The square root of x squared is x. The square root of y to the 5th is the square root of y to the 4th times the square root of y, which then this is y squared. So that gives me on the outside 2x y squared. On the inside, the square root of 3y. Careful, Krugs. I did it yesterday too. Every time. What's up?
Why is it like 6x y?
Why is what? Hold on. Freddie was laughing too hard. Kruger hitting the door.
Why is it 6x? So why did the second square root of y?
Why is it not 6? Because I don't, with numbers, I only divide exponents by the index. Okay? You know what I mean? I don't divide the numbers. Numbers I gotta do a different way. With exponents, I divide them by that index. Okay? So here we could have done 5 divided by 2, right? Is 2 remainder 1, right? So that's why it's y squared on the outside and just a y on the inside. Okay? Right? But yeah, with numbers, I got to actually figure out what times what gets me that. With me? Okay?
Oh no. I was really close to the test.
Okay? Cube root of 128. What? 2 and 64, because, oops, we went this way. The cube root of 64 and the cube root of 2. So this one becomes 4. So that gives me 4 times the cube root of 2. Lots of people forget to put the cube root part, and they just put square root. Okay? Lots of people got ones wrong on the formative.
So you always bring that down.
It stays with you the whole problem.
Got it.
Yep. Unless by rational exponents you change it. Okay? Cube root of 16 here then. So that's going to be the cube root of 16 times the cube root of x to the 4th times the cube root of y to the 6th. Well, that's going to be the cube root of 8 times the cube root of 2. That's going to be the cube root of x cubed times the cube root of x. This is 2. This is x. This is y squared. So that gives me 2
Don't hit you.
x y squared times the cube root of 2x. Yes, ma'am. Because 16 is not a perfect cube. 16 is a perfect square, it's 4 times 4. And it's a perfect fourth, it's 2 times 2 times 2 times 2. Okay? But it's not a perfect cube. So? Yep. So, today what we're going to start is we're going to start multiplication of radicals. Okay? Then on Monday we will be, I believe it's adding and subtracting radicals and picking and continuing that on Tuesday, and then we will divide radicals Tuesday and Wednesday. Okay? Which then gives you enough time to have a formative on Thursday of next week. Okay, so another formative next week, Thursday. Okay? Alright? So, there are two different thinkings that are going on here with radicals. Because there's two different ways to do it. Okay? Just like with multiplying fractions. Okay? The property that we are going to be dealing with is going to be when I take the square root of a, or radical a, let's even go the nth root of a, okay, times the nth root of b, that is going to be equal to the nth root of a times b. Back when we were multiplying fractions, back in 4th grade, you learned that you could simplify first and then multiply, or you could multiply first and then simplify. Okay? Same thing with radicals. You can simplify first, so the square root of 4 times the square root of 9 is 2, because the square root of 4 is 2, times 3, because the square root of 9 is 3, which is 6. Right? Or you could say the square root of 4 times the square root of 9 is the square root of 4 times 9, which is the square root of 36, which is 6. Okay? Doesn't matter which way you go. You've actually been doing it because we did it right here. That's what we did on all of these warm-up problems. You just didn't know that that's what you were doing. And you were multiplying radicals. Okay? Now, 4 and 9, square root of 4, square root of 9, those numbers are kind of small. But 16 times 25, that's kind of a big number. And since we're mean and don't let you use a calculator in this unit, it might be easier to simplify it first than it would be to actually multiply it out. Okay? So the square root of 16 is 4. The square root of 25 is 5. 4 times 5 is 20. Okay? Because you might not realize that when I got 16 quarters, I got $4. So 16 times 25 is 400. And the square root of 400 is 20. Okay? Again, either way works for me. Okay? So, when you get something like the square root of 8 times the square root of 32, okay, you could write that, or you could do that as, let's see, let's do that one in red. You could do that, well, what's 8 times 32? 6, carry the 1, 256. Right? You could multiply that out, but that number's getting pretty big. Right? Okay. And then you might not realize that the square root of 256 is 16. Okay? Because it's kind of a big number. Right? So we could do it a different way. We could do this as, well, what's the square root of 8? What? But can we break it down?
Yeah.
To what? Square root of 4 and square root of 2. What's the square root of 32? Even bigger. 16 and 2, right? Okay. So then this becomes the square root of 16 times the square root of 2. Right? So what's the square root of 4? That's 2. What's the square root of 16? That's 4. So this becomes 8 times the square root of 4. What's the square root of 4? What's 8 times 2? 16. It might be a little longer to simplify first, but your numbers are smaller and more recognizable. Okay? You know what I mean? Okay? You don't have to do that big 8 times 32 and figure out that that's 256 and then remember that that's the square root of 16. Or, if you don't remember that that's the square root of 16, then you got to break down 256 as, you know, it's 2 times 128. And then that's 2 times 64. And then that's 2 times, you know, and on and on and on and on and on and on. Okay? Alright? So, yeah. Okay? Now, in number 2, okay, we could apply our power properties that we learned earlier this week. Okay? And we could say that this is 5 squared times the square root of 3 squared, right? Which is 25 times 3, which is 75. But what if we forgot all of those? What can we do? We can write it as 5 times the square root of 3 times 5 times the square root of 3. And what's 5 times 5? 25 times the square root of 9. So that's going to be 25 times 3, which is 75. Okay? What I would like you to do now is I would like you to do 3, 4, 5, and 6. Okay? So we're going to spot check number 4. So this would be kind of like the square root of 7 times the square root of 2, right? The only thing I can do, even though I know they're not perfect squares, okay? But I can also look ahead and I can say, well, this is the square root of 7 times the square root of 5, right? Even though that's a bad 5. Don't hate me, Megan, because I made a bad 5. Is that better for you? Okay. Alright? Now, I'm going to do some crazy math. I'm going to say that these two multiplied together is the square root of 49, and these two multiplied together is the square root of 10. Now why did I do that? Because the square root of 49 is 7. So this is 7 times the square root of 10. Okay. Want to do any more of them while we're still going, or do you need more time? More time? All right.
2 square roots of 2 square roots of x cubed, 3 square roots of 6 square roots of x.
Okay. Oops, even with bad x. Sorry, Megan. Didn't lift up enough. Okay. So this one becomes x. This one becomes the square root of 2 times the square root of 3. You'll see why in a minute. Okay? Then these two become a 2. Oh, that's way too confusing. Hold on, tap the brakes. We're going to back up a step. We'll just go like this. We'll make it not so confusing for those paying attention at home. We'll just make that one x. Okay? So then that becomes 6x times the square root of 12x. Right?
How did you get x from x cubed?
Oh, that's a 3. That's a bad 3. All right, tap the brakes. Guy can be wrong once on his second attempt at doing this problem. So third attempt at doing the problem. This is x cubed. See, still a bad 3. Ay, caramba. There, now I can see that it's a 3. So then that becomes the square root of x squared and the square root of x. With me? Okay, so then this becomes x, and these two become another x. Right? Because the square root of x times the square root of x is the square root of x squared, which is x. So that gives me 2 times 3 is 6 times x squared times the square root of 12. Do I like the square root of 12? Why not? Into square root of 4 and the square root of 3, right? So this gives me 12x squared times the square root of 3. Okay. Now, if you get too many radicals like that, what's your other option? Combining them all into one, right? So I'll do this next one where I combine them all into one. So this becomes 6 from the 3 times the 2 times the square root of 72. Right? Well, now what's the square root of 72? square root of 36, and square root of 2. So this becomes 6. So I get here 36 times the square root of 2. Hmm?
Can you do it the other way too?
Which other way?
The like
The lots of ways?
Yeah.
Okay. So the lots of ways would be 3, square root of 4, square root of 3, right? Times 2, and then I'm going to go square root of 3 and square root of 2. Okay? With me? Because then the square root of 3 and the square root of 3 here make me a 3 on the outside. Yeah. And that one becomes a 2. So 3 times 2 is 6, times 3 times 2 is 36, times the square root of 2.
Why does it make a 3 on the outside?
Because the square root of 3 times the square root of 3 is the square root of 9, which is 3. Yeah. This could be the cube root of 216, which is just 6. Okay. The smaller way? Okay. So with cube roots, it's kind of hard. So I would go cube root here of 3. Cube root of 3, right? And then 24 is the cube root of 3 times the cube root of 8, right? Okay. Now, because it's cube root, I'm not looking for 2 of them. Like over here, I was looking for 2 of them. I'm looking for 3 of them. So these 3 together give me 3. Okay? And the cube root of 8 is 2. So then those 2 combined get multiplied together to be 6. Okay? Yeah, buddy? What's up?
Are we gonna be playing?
Not tonight. Do you want your formative though?
Yeah.
Okay. So you guys do 7, 8, and 9. How you want to do 7? Combine them all into one? Or keep them small? Keep them small? Okay. So then this would be the, oops, I got to get a marker on. So then this would be the cube root of 3 times the cube root of x squared times the cube root of 3 times the cube root of 3 times the cube root of 2 times the cube root of x to the 5th. Now, why did I go, instead of doing cube root of 9, why did I do cube root of 3 and cube root of 3? Because now there's 3 of them, right? Okay? So these 3 all get me a 3. Then I'm left with the cube root of 2 and the cube root of x to the 7th. Right? Can I simplify the cube root of 2? No. Can I simplify the cube root of x to the 7th? Yeah? So that one becomes the cube root of x to the 6th times the cube root of x, and this becomes x squared, right? So my final answer here is 3x squared times the cube root of 2x. Okay. combine them or keep them separate? In number 8. Separate? Okay. So then this would be the square root of 3 times the square root of y times the square root of 9 times the square root of 3 times the square root of y squared. This one is y, this one is 3, and these two make up 3. So that leaves me with 9y times the square root of y. Now, it might be helpful for you when you're doing it the long way if you would say, so I used this one and I used that one, you know what I mean? Okay, and then that one became the 3 and this one became there, so you can kind of play along with crossing out what you've already used. Okay, might be helpful. I just thought of that too. Okay. You know, I mean, it's a your preference type of a thing. It really is. It's you do what you do to make you be successful. Okay? Yep, you do you, I'll do me. You know what I mean? Okay? So here, knowing what you know about radicals, what's that squared going to do to that square root? It's going to take it away, right? But I also got to square the 3 because the 3's on the outside. So this is going to be 3 squared times 2x cubed y. Well, that's 9 times 2 is 18 x cubed y. And you should, because there's more than one way to get to Mosinee.